So lecture number 13 and 14. In the lecture number 14 there is nothing more for the gate examination, and so there is few slide in this lecture, basically in the lecture number 13. So we have seen in the previous lecture that if our data sequence is 1 0 or 0 1, in that case output is 0. If 0 0, output, that is sample value, is -2, and for 1 1, that sample value is 2 here also. So 1 1, sample value is 2. So but the problem is that due to this transition data, that is from 1 0 or 0 1, in that case you are getting output, the sample value is 0. So for that you have to know the previous bit, then only you can decide that this bit is complement of the previous bit. So due to dependency of the previous bit, the error may occur in the decoded sequence. Suppose here previous one is 1 and the next one is 1, so here output, the sample value will be 2, but due to noise you receive that as 0. So 0 means the complement of the previous bit. So here is the problem, complement of the previous bit. So the previous bit was 1, the complement is 0, so decoded output is 0. Previous bit is 1, complement is 0. So similarly for the next all are sample value, all are 0. So these are the not due to noise, these are the correct value. So the output is the complemented value because all the samples value are 0. So all are the error. So the string of error, the error is propagating due to this noise error, right? So this is the problem. So this problem is basically due to the transition. So this is solved by the lander, and he suggests to do some pre-coding to avoid this error propagation in this duo binary type of pulse shaping. That is the Nyquist second criterion. So Nyquist second criterion is basically duo binary type of pulse shaping. We have already seen this in the previous lecture. So the pre-coding is that, suppose this is the data sequence, AK is the data sequence, you first do some mapping, that is BK. You map AK to BK by this relation. This AK is BK is AK XOR BK minus 1. So this is the block diagram. So AK is the data, and it is here is the BK, and the delayed version is BK minus 1. You are doing XOR with that. So this is some kinds of differential type of things we are doing here. So here is the impulses, and here is a pulse shaping filter, and you are getting the output or the sample value AK. So this sample value could be 2, -2, or 0 because of our specific pulse shaping in the pulse shape PT, that is the Nyquist second type of pulse shape or the duo binary type of pulse shape. So this, if the input data is 0, in that case BK is BK minus 1 from this relation. If this is 0, this is BK minus 1, and if it is 1, if AK is 1, then BK is BK minus 1 complement, right? So in case of this AK is 0, your output will be XK will be 2 or -2, because your BK and BK minus 1 same. If they both are 1, then output is 2, this output AK, and if both are 0, the output will be -2. Now if AK is 1, then BK equals to BK minus 1 complement, so they are in complementary each other. So the AK will be 0, because the suppose previous one is 0 and the next bit will be 1, so 0 1, it will constitute AK as 0 due to the pulse shape, specific pulse shape. So you have 1-to-1 relationship, that is for 2 and -2 your data sequence is 0, and for 0 your data is 1. So there is no ambiguity for the transition. So then this solve the problem of the error propagation. And now is a modified duo binary scheme. The idea is that the purpose is to place some DC null at the 0 frequency, place some DC null, right? So how to do it? And the idea is the making the area of the pulse equals to 0. So here is one sync pulse, and here is one sync pulse, that is at -T naught and T naught there is two sync pulse, and if you combine together you will get the pulse shape where the area is 0. And the decoding technique will be different for this case, and we are not going to discuss those here, because as far as the GATE syllabus concerned, these are not important. But you should know that the modified duo binary scheme is to introduce some DC null at the spectrum, right? And this is the pulse shape.